Water, the basis of life. In its purest form, it sustains life, soothing parched throats to quench thirst, and adding a dash of green to dry, arid lands. Nature has endowed us with this life-sustaining magical liquid, providing through the rains, the rivers, and the rivulets. But how long will this seemingly perennial source sustain life? Or have we overdrawn from nature already? And is it too late? But to correct this imbalance between demand and supply of water is the Council of Scientific and Industrial Research, CSIR. CSIR is the premier organization for scientific and industrial research with a network of 38 laboratories and 39 regional centers in the country. Indian scientists have worked hard under the CSIR to develop new and cost-effective technologies to provide safe and pure drinking water. Central Salt and Marine Chemicals Research Institute in Bhavnagar, Central Glass and Ceramic Research Institute in Kolkata, Industrial Toxicology Research Center in Lucknow, National Environmental Engineering Research Institute in Nagpur, National Chemical Laboratory in Pune, National Geophysical Research Institute in Hyderabad, and Regional Research Laboratory in Bhubaneswar. All these institutes are doing a pioneering effort to provide pure and safe drinking water to its citizens. CSMCRI has evolved two technologies such as ED or electrodialysis of water and reverse osmosis RO. Both these technologies look at treating wastewater and reusing them after recovering the potable and usable water from them. The technology is based on the premise of retaining the purity of water and removing impurities to provide drinkable water. Two types of membranes, cation and anion exchange membranes, are used in electrodialysis. These membranes are arranged alternately, and the solution to be treated is passed between them with an electric field across all sets of membranes. These units can be used to convert brackish water to potable water and remove fluorides from drinking water. CSMCRI has developed domestic as well as community ED units to help desalinate brackish and seawater into potable drinking water. The domestic ED unit is designed to treat about 3000 ppm parts per million or less brackish water and gives potable water of about 5000 ppm total dissolved solids at an estimated rate of about 12 to 15 liters per hour. CSMCRI has been able to build an ED unit with dimensions up to 100 cm by 50 cm with 150 cell pairs of ion exchange membranes, which can produce 800 liters per hour of water of 500 ppm total dissolved solids from a feed water of around 3000 ppm brackishness. The other major technology that has come out of CSMCRI is the reverse osmosis or RO technology. In RO, water is demineralized using a semi-permeable membrane at high pressure. Reverse osmosis consists of a sand filter, cartridge filter, booster pump, high pressure pump, and membrane airing and control panel. In osmosis, water enters the salt solution through a semi-permeable membrane. While in reverse osmosis, due to application of sufficient external pressure to the salt solution, pure water flows out of salt solution through the semi-permeable membrane. CSMCRI has been able to manufacture a durable membrane called the Thin Film Composite (TFC) membrane for desalination of brackish water. The TFC membrane is a two-layered polysulfone polyamide membrane structure supported on a non-woven polyester fabric. This membrane has given satisfactory results, with 95% of the total solids being rejected from the brackish water containing up to 10,000 ppm of brackishness. Based on this indigenous TFC membrane technology, CSIR has installed a 1 million litre per day RO plant for the treatment of tertiary treated sewage water at Chennai Petroleum Corporation Limited at Chennai. For this revolutionary effort, CSIR has bagged CSIR Technology Award for the year 2004. Reverse osmosis is the cheapest and the best way to purify water at a mass level. Depending upon the quality of the water to be treated, the size of the aperture of the membrane is selected. There are a number of benefits of using a reverse osmosis technology to convert brackish water to drinkable water. Since the sizes of such plants are small, installing them becomes very easy. Simple design makes maintenance of the plant unproblematic. It is also highly cost-effective. Underground brackish water costs about 3 to 4 paise per litre for desalination, and it costs about 10 paise per litre for seawater desalinization. Reverse osmosis also comes as a major boon for production of highly purified and distilled water that are required for medical purposes, as well as some industries which require water with high purity. As part of the reject water management, the Institute has developed a cultivation technology under the Wasteland Development Program, which utilizes the saline effluent, that is the reject stream, for irrigation of salt-resistant plants called halophytes. The existing RO membrane developed by CSIR is capable of removing 90% of fluoride from feed water. In fact, RO mobile defluoridation unit based on TFC membrane was successfully demonstrated in 6 villages of Nalgonda district of Andhra Pradesh. Since the majority of the country's population depends on underground water for drinking, it is imperative that these technologies work in these regions for it to be called widely successful. Such underground water is usually brackish and not to be consumed directly. Here, CSIR has been able to successfully intervene and set up RO systems for communities, which is basically a 100 litre per hour desalination system. Kutch district of Gujarat, a region prone to water scarcity, is a beneficiary of this technology. Since these units are meant for places far-flung, non-conventional energy is being harnessed.
Any water purification process has an input energy, and where is this energy going to come from? I mean, if you are in an urban area, there is no issue. Even of course in many of our villages today where you get electricity, there is no issue. But if you were to go to coastal areas where there is no electricity in many locations, and also in remote villages where people might be requiring water, this whole business of the source of energy becomes important. You will see the work that we have done on the use of oxen or camel to do desalination. It was a totally new concept. No one had thought of it before. We did it simply because of this need that we felt.
Into eliminating different types of arsenic contamination in groundwater, Central Glass and Ceramic Research Institute in Kolkata has developed an improved ceramic membrane technology for community application. This system of purification has been accepted widely. CSIR, with the help of government funding, has installed 6 units of this plant at various locations of West Bengal. The initial investment for installing the plant is only Rs 2 lakhs. The operational cost is raised by the local people through some NGO or self-help group. As the cost is very reasonable, local people are easily ready to pay for this arsenic and iron-free water. In other endeavor to combat waterborne diseases, particularly in rural areas, Industrial Toxicology Research Center Lucknow has developed a household low-cost water filtration assembly called Amrit Kumbh. In this assembly, the immobilized silver impregnated activated alumina has been filled in a candle. The disinfection process is based on physico-chemical principles. The essential physico-chemical components and minerals remain unchanged in the filtered water of Amrit Kumbh, and the filtered water meets safe drinking water criteria. It can efficiently filter approximately 10 liters of water per day for 3 years. In the condition of retarded filtration, the material in the candle can be cleaned simply by washing with water and refilling. ITRC has also developed a water analysis kit. This is a one-piece kit for physico-chemical and bacteriological analysis of water to determine the drinking water quality from public health point of view in rural areas. Like ITRC, Regional Research Laboratory Bhubaneswar has also developed a low-cost water purification mechanism. The red clay water filtration media, called as TerraFill, is a burnt red clay porous media used for filtration and treatment of raw water into clean drinking water. TerraFill is made in shape of a solid disc having 50 mm thickness and different diameters as per requirement. The TerraFill disc can be fixed directly with bottom of any container through epoxy resin or cement or any adhesive which is not harmful to human being. The upper chamber holds raw water and lower chamber stores the filtered water. The TerraFills are fitted on the bottom of the upper chamber in such a manner that water can pass through the TerraFill only. The chambers can be made with any material such as stainless steel, terracotta, food-grade plastic, ferro-cement tank, etc. The Polymer Division of Pune's National Chemical Laboratory, NCL, has come up with a new membrane filter that ensures the quality of drinking water. A unique aspect of the ultrafiltration membrane is that not only does it clean the water of all suspended particulate matter and bacteria, it also gets rid of harmful viruses. This membrane technology does not depend on electricity, unlike other water filters, so it can be easily used in remote rural areas as well as disaster zones. On the other hand, excess fluoride in drinking water is a major problem in semi-arid tropics of India. National Geophysical Research Institute, Hyderabad, has developed and piloted an experiment of in situ dilution of fluoride content in groundwater tapped for drinking water supply using rainwater harvesting and artificial recharge, and successfully supplying a safe drinking water with fluoride content of 0.4 mg per litre. Delhi, the capital of India, is spread over an area of 1,483 square kilometre, having a population of around 14 million. There are 28 approved industrial estates in Delhi. These estates house a large number of small and medium-scale industries and generate around 200 million litres per day of industrial effluent, which is directly discharged into river Yamuna, including 2,000 million litres per day of sewage from Delhi. The Delhi Pollution Control Committee entered into an agreement with the National Environment Engineering Research Institute, Nagpur, for the design of Common Effluent Treatment Plants (CETPs). Wastewater from the industrial estates are routed to the respective CETPs for treatment. The combined wastewater is collected in the receiving sump and then pumped to screen and grit chambers where large objects, grit and sand are removed. For physiochemical treatment, the equalized effluent is pumped to pre-chlorination tank. The pre-chlorinated effluent is routed to flash mixer where it is mixed with the coagulants and then flows to tube settler. Thereafter, the clarified effluent is pumped to dual media filters followed by activated carbon columns for removal of pollutants at tertiary level. The settled sludge from the tube settler is thickened in gravity thickener and the thickened sludge is routed to sludge collection tank. The tertiary treated effluents from the CETPs are finally discharged into various drains, finally meeting river Yamuna. The outcome of the treatment technology options developed and implemented through establishment of common effluent treatment plants are enabling the major small-scale industries in the state to comply with the environmental norms of the statutory board. Today, the implementation and operation of the 10 common effluent treatment plants designed by the National Environmental Engineering Research Institute enabled significant reduction in the pollution load being discharged by the industrial estates into river Yamuna. Ultimately, good health water consumption makes for a longer, disease-free and healthy life. Taking contaminated water for over a long period of time is detrimental to human health, as seen in the cases related to waterborne diseases all over the country. West Bengal is struggling with high level of arsenic in the water. Andhra Pradesh has high level of fluoride. Tamil Nadu has saline water, whereas the water in Rajasthan is not only saline but also has high level of fluoride. Gujarat is also struggling with the hardness and fluoride of water. In all these states, CSIR is trying to provide pure and safe drinking water. By using CSIR technologies, we have probably found a permanent and sustainable answer to the question of water problem in the country forever. If these technologies are adopted universally in India, then water everywhere for everyone will become a reality very soon.